So today we are going to see different modules and about the kernel. So kernel is the most important, the central core of the Linux operating system. So in the third module we'll see about the Linux kernel and the different methods, the different files which are present under /dev and /proc directories, and followed by the most important commands that are necessary in order to, from a system admin perspective, how to check the processes, what is the memory usage, how to check the disk space, how to kill the processes, how to check the current status of the processor, instantaneous status of the processes running in the system. We'll get to see all the important commands. So starting with the Linux kernel, which is the core of the Linux operating system. So it basically helps you in connecting, it acts as an interface in between the software and the hardware part. So as I've mentioned before about the architecture part, if you want, you can check the architecture using, there is a command called uname-a. So where you will get to see the information about the system and the architecture as well. Here it is x86_64. Similarly, if you want the version of the OS that you have installed, you can get it from that file etc red hat-release. Okay, so this is a 64-bit. So it supports, there are two different types. One is 32-bit as well as the 64-bit. Okay, so and there are some limitations for both 32 as well as 64-bit. It can support, the 32-bit can support a maximum of 4 GB RAM. So they are represented as x86. So if you observe here, there is another kind of kernel-EAE. So if you want to add additional RAM, if you want to have additional support of RAM, you can go ahead by installing this particular kernel. That would help you in supporting higher values of RAM in a 32-bit system. Alright, so by default 64-bit supports RAM higher than 4 gigs. So as a part of your kernel is basically a set of modules. You'll get to see a list of all the modules. I'll show you the different commands that you can use in order to list all the modules, but we will not be making any changes, just for understanding. So how to list the modules in case if there is a need, how to insert, how to delete a specific module from the existing list. Alright, so all these modules are linked to the device drivers and the firewall kind of security related modules you will get to see, and also you'll see all the file system related modules as a part of your kernel. Alright, so these are the important utilities. One is a list mod, using which we can list all the modules. Okay, so if you observe here, you can see IP tables. There is something called IP table in this list, which is related to the security part. So like that, we will also get to see the device related modules in this list. Okay, so like that, so ls mod will basically display all the modules which are present as a part of your kernel. So okay, so if you want to remove a specific module from the list, so rm mod is the command to remove the modules. And then if you have downloaded a module and if you want to insert it into the kernel, existing kernel, you can load the module using insmod command. Okay, so what I'll do is I'll try to download some module and we can, so that we can perform these operations. We can add, insert and make the changes to the existing module list. Okay, so before that, so mod probe, it loads and unloads the modules. So basically every module also have dependencies involved. Okay, you can check the dependencies using the depmod command, and then you can use mod probe command in order to handle these dependencies, in order to insert them back to the kernel. Okay, so this is pretty much. So usually most of the time you won't get to use any of these commands, these are like a bit advanced level handling modules and all, but we'll perform. I'll show you how to insert and remove the modules, but since this is a bit advanced, we'll take it to the I'll show how to perform those operations in the next session once you get familiar with the rest of the system processes and Unix system altogether. Okay, next is your init RD image. So in your system, if you go to /boot, alright, so here you'll get to see this init ramfs, a file called init ramfs. Okay, so you can also get to see init RD image here. So basically init RD, init ramfs, they perform similar operations. They are a temporary file system. Alright, so what happens is, apart from the file system that you see currently, when you try to install or when you start your system, basically the temporary file system will get mounted initially. Alright, so this gets mounted during the system boot. So this is what the file system that you will land up when we use the single user mode. If you remember, we have modified the grub line, going to the grub page when you start your system. There we have logged into the single user mode. So that is your temporary root file system, wherein we can change the root password. Okay, so that is the init RD image that would get loaded into your system. All right, so you can also create these images. If there is a new init RD image available, what you can do is you can download it, and here are a few steps on how to create it and use it under the /boot directory. So if you remember, here let me show you my grub.conf. Okay, so if you see the grub.conf here, there are two kernels present. So I hope you remember in the previous session we have discussed about this. Say what is the current version of the kernel we have. In case if there is a latest version of kernel available, we can download that RPM and we can install that RPM. So usually this is the scenario that comes up when there is a need to test a higher version or any other version of the kernel that is available. So in order to test that, we can download the kernel. We can make an entry in the grub.conf. When you restart your system, you will get to see both the kernels. So you can select the latest kernel and you can start your system, and you can see how the kernel is performing. So similarly, just like this, there is another way. So this is another way of if you have a latest init RD image, you can download it and you can follow these steps, and you can place it in the same location, and you can start making use of the init RD image as well. All right. So I've told you, if you remember, right, in a Linux file, in a Linux operating system, everything is considered as a file. Okay, so we have seen normal files, even directory is a kind of file. All right, now I will show you some other types of files that are available. So if you can see your all right, so we have other folders like /dev and /proc. Okay, so there you can get to see some other types of files. I'll show you now. My VM is starting. So there you can get to see block files or block device files. We can see other files, other types of files as well, like piped files and character device files, like that. So there are different kinds of files. In fact, every device, every device is represented as a file. There is a corresponding configuration file. So while interacting with that device, the corresponding configuration file has to be modified. The corresponding driver file will come into the picture, and that will try to act as an interface in between the you and the device itself. All right. So 1 second. I'll show you those files. So here itself, if you can see, I hope I'm audible to everyone. Can just one of us, can you please confirm? Okay, thank you. I got it. All right. So here, if you can see, there is a long listing of the files under the directory called /dev. Okay. So here there are multiple device files that are being listed. Here you can see the file that starts with C. It is a character file. All right, and you can see linked files, small l. They are linked files, and then you can see B that represents the block files. All right. So mostly all your disk related files are represented as block files. All right, and there is another kind of files called as pipe files. All right, so these pipe files, they act as an interface between two terminals. That means you can send a message from one terminal and it gets broadcasted in the other terminal. We'll see that as an example. See, most of the time, other than your normal files, text files, scripts, directories, and then linked files. So these are primarily the kinds of files we'll mostly be working on. All right. So rest of the file types are just for the sake of understanding. So if you take a device file, block device file, so the best example is your disk related files that handle blocks of data, chunks of data. So they have a different notation called as block files. All right, when you try to interact with the disk, automatically the corresponding driver will come into the picture. All right, so similarly, there are for every driver there is a separate block file associated with it. One second, I'll show you an example here about one of the type of the file called piped file. All right, TTY is your terminal. So just this is a very basic example of, you know, I've created a piped file for you. Testing pipe. Okay, so if you observe here, right, so it's almost like whatever content that you pass it to this type of file, you can observe this /temp pipe. I mean, I've just given the general pipe as the notation. So here this is a piped kind of file. All right, so this is the file I've created. I mean, usually we don't create such kind of files. So there is a different example altogether here. Here, what he has done is he has echoed to something called /dev tty. So even that is one kind of. It's a character file. Okay, so basically whatever content that you pass it to these kind of files, what it does is it's like temporarily it will keep the content, and if you try to access the same file again from a different location, it will try to give you all those content. So these are like special kinds of files. All right, and you can see here how it works. Here from this terminal, when we pass a message to this character file, automatically the same message will be broadcasted in the other terminal when you try to access that. Okay, so these are like this is how they handle the data. They handle the chunks of data as well, which you can pass it considering, I mean, you can make this file as an interface and you can pass it from one TTY to another terminal as well. But mostly we won't be making use of these files, but just for your understanding, there are other types of files other than normal files. We have block files, we have character files, we have piped files and all. Okay. So these are some of the examples. It's like block device files like /dev HDA. In my system, if I do fdisk -L, okay, so here /dev SDA1 and then you have SDA2. Okay, so these are block files. Like that we can see other files. So for every device that we create in our system, there will be a corresponding file that gets generated. Okay, so whenever we try to save something in the disk, there will be an interface through this particular file which will help in saving the data to the corresponding disk. Okay, here if you see, there is something called /dev MD0 and MD1. So these are related to logical volumes that we create in the system. All right, so either logical volumes or something. Yeah, one second, Rajkumar, I'll just finish and then I'll unmute you. All right, so here if you see, there is a concept called LVM, Logical Volume Manager. We'll see how to create logical volumes. So basically you can imagine it like a container. All right, so so far you have seen that in Linux there are partitions, just like in Windows there is a C, D and all those drives. Even in Linux we have partitions. So this is the command, fdisk-L is the command using which you can see the partitions. Okay, so here /dev SDA1 is one partition and /dev SDA2 is considered as another partition, but if you observe here, it is called as Linux LVM. So it's a logical volume manager. So you can consider this as a container that hosts sub-partitions. All right, so there is some restriction to the number of partitions that we make. So rather than limiting ourselves to the number of partitions, what we do is, so we create one primary partition and then we go on with the LVM concept, so which we'll see later, wherein we create a container inside which we can create n number of partitions, sub-partitions. Okay, so these partitions, so these kind of files are represented as MD01 like that. Okay, and then these are terminals. You can open in the UI, you can open n number of terminals and simply type TTY command and see this list of terminals that get created. And another one called as /dev/null. Usually this is like a black box. Okay, so wherein usually this is used in kind of applications where whatever output that comes, right, parallelly you want to save at some place or you want to completely delete it from the system, redirecting that output to /dev/null, okay, will completely delete it completely from the system. It's like a black box. So what happens is when running some applications, the output, there are three kinds of messages that keep generated. So standard input, standard output and standard error. These are three notations that are available. So we usually, whatever we give as an input, it is the stdin. So when you execute the command, I'll give you a quick example to understand this. All right, so when we are running something, right, so whatever output comes when it is displayed to your screen, so that is your standard output. Okay, and apart from this, if there is an error associated when you execute a script or a command, that is called as the standard error that comes to the screen. Okay, So the reason why I'm talking about these three parameters is what happens is when running some scripts or applications, so whatever that comes to the screen, rather than displaying that output at the screen, we redirect that content to /dev null so that it is completely lost. So there are two ways. So when executing scripts, okay, so you might want to log the output whatever comes. So among that there can be standard output, there can be standard error as well. All right, so you might want to redirect standard error to a file, and whatever standard output comes, that is something you are already aware of. So what you do is you redirect that to /dev/null, so that would be lost. Okay, so that is one kind of file. Okay, so like that we have different types of device files available in the system. And regarding /dev/null usage of this, I will show you. I will come up in scripting topic. So I'll write a script wherein we can redirect the standard output to a file. We can store that just like creating logs, and we would also redirect the content to /dev and null. All right. So after going through the files which are present under /dev, the next one we will cover is /proc. We'll come to the /dev part later. So if you observe /proc, you can hear you can see this on the screen. There are a lot of folders, particularly marked in blue, right? Let me tell you. I'll give you an example of this. So all process related, /proc stands for process related files. Okay. So I'm just I'll explain this command later. What I'm trying to do now is I'm trying to generate. I'm trying to list a set of processes in the system, and I'll show you the corresponding process ID as well. All right. So what happens is for every process there is an associated process ID. And for every process ID, there are certain parameters. Okay, so those parameters are present in a text file, and there is a under /proc, which is the process related directory. Under that directory, so with so whatever process ID which is there, so with the name of the process ID, folder gets generated. The moment you run a process, there is a folder that gets. Okay, I'm sorry. Okay, so I'm talking about /proc. Okay, /proc. See all this? Yeah. So under /proc, I was talking about the folders which are present under /proc. /proc is for process related information. So if I ps-eaf, I'm just this command used to list the processes. We'll use go for the okay. So if you can see, this is the corresponding process ID that got generated. Okay, so here if you observe, right, corresponding to this process ID there will be a folder. Okay, you can observe this, right? So whatever command that we have used, it runs as a process. So bash is running as a process, so there will be a corresponding folder that gets created under /proc, and in that all the parameters or whatever values that represent that particular process, they will be stored inside this particular folder. Okay, so this is what I wanted to show you with respect to /proc, all the process related information. So how does it get generated? Where does it get stored? So this is where it gets stored. The moment you start a process, automatically it gets generated here. Yeah. So among all these files, I just want to show you the output of this file /proc. Okay, so this particular file, it defines the limits for that particular process. Okay, some of the hard limits and soft limits are present here. Usually if you are running a particular application, okay, so there will be limits that are being set for that application. So the number of files that you can use, the maximum number of files, the maximum amount of space that you can use, like that. You have all the parameters here. Say if you want to modify any of those parameters, you need to make the changes here. All right, so this is why these files are important. So this is the one of the important use case. I'm not going deep into all the other files that are present under /proc, but how they are generated. So the moment a process gets started, there will be a folder with the process ID under /proc. You can go to the inside that folder. You can see all the parameters defined under different files inside that folder, which is generated with the process ID. Okay. If you can see here in this example /proc/1, one is the ID process ID for the init user, the grandparent of all the users in the system. So that is the example that has been taken here. Similarly, some of the other files which are present under /proc are meminfo. You can see CPU info, information about the memory, CPU and all. But usually we don't go and check these files for the information. There are some tools available, some commands available handy. So we use those commands, but for the information's sake, so we can also open the /proc meminfo, where we can get to see all the amount of space total memory that has been allocated, the free space, buffers and all. So this /proc/version, so the one we have seen, we can also get this version using the command we have used before, that is uname space -a. It's the same output that uname gives. All right, and this is CPU info. Okay, so there is another command that I'll show you that is called as top, that gives the instantaneous status of the processes that are running in your system. It also shows you the memory information and also the CPU information. So basically this particular file, say you have a dual core or quad core CPU, right? So all the information about the CPU will be displayed here. The number of cores, if you want to quickly check the number of cores of your system, you can come and open this file and check the codes. You can also check using the top command as well. I will show you that in some while. Okay, the next one is /proc/partitions. Let's see that in my system. Okay, so if you see here, so these are the partitions: SDA1, SDA2, all right, and then you have DM0, DM1. Okay, so there is something called a major number and a minor number here. Okay, so this major number corresponds to the type of partition. So this is SDA partition, all right, and among SDA, the order starts with 0, 1 and 2. All right, so 8 represents the kind of partition, and then 0, 1, 2 represent the order of the partitions, SDA, SDA1 and SDA2. Similarly, if you observe here, so this is one kind of partition, and among these two partitions, this is 0, 1. If you create another LVM here, it will be DM-2, and then the major number would remain the same and the minor number will be 2 for it. So here it's just the SDA. In my machine there is LVM as well, which I have installed before. Alright, so here some other files. If you see here /proc/sys /net IPv4 IP_forward. So under /proc, you would also get to see files containing parameters which are directly related to kernel. Okay, so the settings, so the set of variables or the arguments which we can pass directly to the kernel and make changes during the runtime. All right, so these are the files which are present, the files which are present under the proc. So if you make changes to these files, specific changes in the sense, say for example IP_forward is the example here. So 0 is to enable, 1 is to disable. All right, so if we make changes here in these files, automatically they will get reflected during the runtime. So automatically the corresponding functionality would get enabled or disabled. All right, so that is the importance of these files. Like that, let's see other examples. Say we have hostname parameter here. So there is a configuration file called /etc sysctl.conf, wherein we can also make the changes which would be permanent. So there are always two different ways of making changes to your system, temporary as well as the permanent changes. Yeah, sysctl. So sysctl is an interface for analyzing and dynamically changing the parameters in the operating system. So all the kernel level parameters, whatever are there. So what we can do is we can modify those parameters. We can make the changes during the runtime itself, and all those changes would get reflected in the files which are present under /proc/sys. Okay, so this is the entire list of all the parameters, and from this list there are some parameters which are important. So some are related to your SC Linux, that is security, advanced security feature, which we'll handle in the later sessions. So then I'll show you those changes that we'll be making directly in the corresponding files. Okay, so it's like I'm just talking about the functionality now. So when the corresponding, whenever those sections would come, then I'll again come back here and I'll show you the changes that we'll make. Then it will be easy for you to understand that. Alright, this is one example here. The maximum process IDs have been set to this particular value. So the kernel does allocation of the process IDs. And you can also manage all these devices, whatever we have seen under /proc, using all device manager. That's a GUI tool that is available. All right, yeah. So let me just tell you this once again. So if you feel that some of the topics are being skipped, or I'm not showing you a demo of the topics, it's just because I'm just trying to prioritize the things. So the way I feel that it will be easy for you to understand, I'm just prioritizing like that, and I'll be coming back again to show you a demo of those topics as well. But it's just that I've just moved here and there, so I will be coming back and show you if you remember regarding the modules, as well as regarding the parameters that I have mentioned now under /proc. I will show you a demo of all those, but when it comes to SC Linux, I will show you that. Yes, Prasad, can you hear me?
Hello.
Yes.
Can you hear me?
Yes,
so Karan, why don't you just do the? I don't see the flow. So why don't you just do the practicals, right? Why don't you just do it? You don't need to worry about the slides. You just tell us what you know and just go through it, and then you can come back to the slide and see if you have missed anything. So what I'm suggesting is that this is what we did in the other class, like the Hadoop class. Tejas just go through it, and then maybe he comes back to the slide, or this is online also the slides, so we can go through it also. So what I thought was that class had a lot of flow in it. You know, we know how his style was, and he was like. So I thought that was more. More practical. Kind of. That is what I think all the people attending the course wants to see. What's happening, not the slides. Slides are okay, we can read it, we can figure it out. You know, that is just for you to have a guide, for us to have a guide, but of what is expected. But more practicals, and then you can come back to this and go through the slide. I mean, I don't know what others think. That'd be great. I mean, when you go into the terminal and you have a flow, then there is a flow to it. And then when suddenly it comes back to the slide, we lose kind of the flow, and we lose track of where we are now. Just a suggestion. I don't know what you think.
Sure, Prasad. Sure, definitely.
Yeah.
All right. Yeah,
You can
we'll go ahead with the practical part. Definitely. Sure.
Yeah. You can mute me. Thank you.
All right. Let's start with some of the important utilities in Linux. Okay, I will start with the free command. All right. So if you can see, this is the amount of memory that I have allocated, and this is used in the free one. So we can also change it to -k. It will give you in KB. We can use -m. It will give you an MB. All right. And there is another argument called T, using which you can get a total of the values that is present. All right. So this command is used most of the time in order to check the memory of our system. All the applications that you make use of, they'll be accessing your memory. All right. So this is the same set of outputs. Whatever we are getting here, we can even see these outputs under /proc mem_info as well. All right. So you can get the available memory. You even get a lot of additional other parameters available here. All right. So total memory, free space, the cached memory. Okay. So here there is a concept of something called as swap memory. All right. As during the installation process, when you perform an installation, right? So we create a partition called as swap partition. All right. So swap is basically a partition. It is created on disk, but it acts as your RAM. When your RAM is full, what happens is the pages will get swapped between your RAM and your swap partition. All right. So basically, that would help you, in managing the RAM which is present in your system. So it is always important to check the value of swap as well. So mostly, as long as you have free space in your RAM, so this should always be 0. The swap utilization should not be there as long as you have sufficient amount of memory in your system. So if that is not the case, so there is a possibility that there is something happening with respect to the memory. So you can start doing some troubleshooting in those areas. So usually that is what we check when we go with this particular command. We see what is the available space, how much is used, and how is the swap status in the system. Okay, then all right. So this command is used to check the status of the partitions or the disks that are currently, or the partitions that we have created. Similarly, with this, we can use -h to make it human readable. All right, just displaying it in terms of bytes, KBs, or MB. We can add additional arguments to make it human readable. So This is another important command. So there is another important usage of df. It's not df. So just like df, there is another command called, so it's like free disk, and du is the command that shows the disk usage. All right, we'll go to some other place and then we use like this. So disk usage. So basically this command will give you the usage of every folder that is present under the slash directory, which is the topmost directory. So one quick example of how this is going to be pretty useful is, like, as an admin, you can always have application logs that keep getting generated, right, in your system, and sometimes what happens is it completely fills your entire disk. So there is a need to clear the logs, or at least archive the logs, in a timely fashion. So if that doesn't happen automatically, your applications or your system will hang. So in case if there is a scenario where you have your disk is completely full and you want to figure out how to understand, so there is a huge tree structure, a lot of directories and subdirectories are there, you don't know how to check it. So one way of understanding is using the du command. See here, if you observe, right, du-sh, it gives the total size of this particular folder. So that to h is, it gives in a human readable format, right? So like this. So among this list, we can quickly identify the folder that has occupied, and you can again go to the subfolder and you can run the same command inside the subfolder and identify it. So this is one way of doing it. Just I'm telling you, there are other commands as well which we will see later. So how we can identify such kind of directories that have occupied a lot of space. All right. Then we have something called top command. So top basically, it gives you the instantaneous status, the status of the processes at a particular instance. At the instance I ran the command. Here, even here, you can get to see the CPU usage, the memory, the swap. All right. So a lot of information is present. Here you can see all users and the corresponding processes that are running. Every time the CPU or the memory, if the consumption changes automatically, it will give you the instantaneous value here. All right. So here another important thing to observe is this. So the load average. So this is the important part. This will give you the load on your system for the past 15 minutes, and then last 5 minutes, and this is the last 1 minute. All right. So we can even monitor this load average. Usually what happens is system admins, they prefer to run scripts, monitor the memory. Once a certain threshold is reached, it will try to trigger an alarm, some kind of script that triggers an alarm, just to check what is if it is a genuine usage or some application is eating up all the memory. Similarly, there are thresholds that are being set just to have a control on the amount of load that is there on the system. All right. So these are some of the important things with the top command. We can even sort the content in the top at a user level, or if you want to have a general listing of the processes, we can go with ps-eif. There you can go through the man pages. -e basically, it will list all the processes that are present in your system. Like that, we can. Oops. Okay, just to list, we have the process ID and the corresponding parent process ID. All right. So, and the system, what is the command that is there, and the user ID, as you can see here. Like this, we can get a list of all the processes that are running in your system. Say, for example, sometimes you might observe that due to extra load, sometimes your Firefox gets hung. All right. Similarly, the same thing happens even in Linux and the GUI part, or some other application is not responding properly, or you want to kill that application. So in order to perform the same operation using command line, we need the process ID of the corresponding process in order to kill the process or restart that particular process. Alright, so PS command basically helps you to give the process ID of that process. So this is the process ID. If you want to kill a particular process, and what I can do is I can get this list and get grep for that particular process. See this one. Alright, so once I get the process, I can simply pass this process ID and I can kill the process. Okay, so here yeah, what I'll show Firefox, killing Firefox as an example here. A lot of applications you can use the GUI, or you can simply try giving the command itself. Okay, so here what I'm doing is I'm trying to start this application from the command line itself. Okay, if I start here, the Firefox will start, but the session would remain like this. Alright, I'll not get the prompt back. So I need to. So what I can do is instead I can run the same in the background using ampersand symbol. So okay, system is very slow here. So what I'll do is I'll show you this top command itself. So when I ran top command, it keeps showing the instantaneous values unless I quit. Right? So what you can do is simply put an ampersand. So automatically, so top command is running in the background. So though it is not needed, just to show you, if you want to run something in the background and get the prompt back, say you are running in run level 3 where you have only a black screen or the prompt where you cannot open other tabs as well. What you can do is you can simply try running the process in the background like this. Okay, keeping an ampersand. Now if you want to check all the jobs that are running in the background, what you can do is you can run the command called jobs. Okay, and if you want to kill, that's what I was saying, right? So okay, so I have opened this. I can use simply kill and the corresponding process ID. Okay, so basically that is how we kill the processes. So basically kill command, what it does is it sends a signal. All right, it sends a signal to stop the execution of the process. So if there are different, I'll just show you for information sake. These are different kinds of signals that are available in the sense that kill usually sends. Okay, but mostly we'll stick to the normal kill command. So sometimes the processes may not respond immediately when you use a kill command. So in such scenarios, what we do is we go with the forcible killing process, that is kill space -9 same, the process ID will be used. Okay, like this. So you can either go with the process ID, and if you are aware of the exact the process name, we can even send the process name as an argument to it. All right. So okay, so far we have seen how to check the disk usage, disk space, about the free space, about the memory, how about how much of RAM has been accessed, what is the swap, all right, and also how do we check the list of processes that are running in the system, okay, and going forward. I mean, these are all the different kinds of signals, so that means kill command. Okay, Rajkumar has asked question about all this. So these are all the different kinds of signals, okay, that kill usually uses in order to interact with the processes inside. If there is a need to kill a particular process, so I'm not familiar with all these kinds of signals, but primarily, so sigint and sigkill, all right, which are right, this one, sigkill, all right. So basically what happens is it will try to immediately kill the process using this, and that is why we use kill space -9. Okay, I'm unmuting you 1 second. Yes, Rajkumar.
Hello. Yeah, I
Yes,
have
I
a
can
quick
hear.
question on this. Yeah, this is means in the real world. Actually, I work with some other software systems, applications, and the way we get some issues and handle the applications is sometimes we get this error from the applications, right? We see that sig sigkill. Means it's like almost it's a bug in some kind of a software. Like that's what I understood from interpreting this sig like the sig variables, right? So I just wanted to know at a high level when how does this how Unix lists this as a output, like what I'm asking, like it's like I don't need to know all these parameters, but even as a basic one like sigkill or sigint, how does that how does Unix like treats this variable and displays it as an output, like with saying like, okay, this is an issue, this is the error thrown, because I see a lot of these things. Means it's not very common, but if I see something like sig init or something, it says it's a major issue, and most of the times it is a bug in the software that is written. So I'm just trying to understand what this is.
All right, let me give you a quick example. I hope you might have heard about the exit status of a command or a process. For example, if you see here,
Yes.
right, I'm running a command here, ls. Okay, so the command execution is successful. Okay, now what I'll do is, so I can see now the command got successfully executed. Say I have a script in which I have executed this command, and I need to figure out a way in order to understand, I mean, whether this command is successful or not. Okay,
Yes.
there is a variable called $?
Right.
Okay, this variable it will tell you whether the previous command was successful or not.
Mm-hmm. Mm-hmm.
Okay, let's try something else. Ls so 0, it's 0 means success. Anything other than 0 means failure. A command has failed. All right, and so the reason why I gave you this example is, so it is not just that the users make use of the kill command, but all the processes that are running in the system, they also make use of the same. So if we do a restart or a shutdown, right? So among list of all the messages that you see on the screen, even you can see that this particular process has been sent a sigint command. That means all the processes will be sent the same command. That means automatically they'll be killed one after the another in a particular order. So say in an application, something didn't work out properly, or you have sent a kill command to that particular process, the next moment you will check whether that has been successfully executed or not. So there is a way, like simply checking $? Whether the killing process has been successful or not. So you can check that. If that was not successful, you cannot continue with your script. You need to ensure that the process has been properly killed in the first place, and after that only there is a condition to proceed further. So in order to ensure that, what you can do is you can again pass a kill -9. That means forcefully you might want to kill that particular process. So like that, system also checks and it sends different kinds of signals. And regarding the standard output that I've mentioned before, standard output and standard error. So every command, when it executes, it prints something to the screen. So all these processes, when they run, so they ensure that whatever output comes, whatever error comes, they get printed to the screen where you can get to see all the signals.
Okay, but when it is printing 2, how can I interpret this 2 as means this variable says sig int, like take any of this example, sig int or sig gp.
Basically, it will only send in this particular format, say kill space -9. Okay, so
Okay.
when -9 has been sent as an argument, then check the corresponding sig kill is the corresponding signal that will be sent. So when you see sig int, that means kill -2 has been sent.
Okay, kill -2. Okay, kill -2. Okay.
So that is how the corresponding signal will be sent.
So the kill minus that the corresponding number and the process ID.
Yes, the process ID. It will kill that particular process. You can give the process name also. So,
Okay,
but you need to know the exact name of the process. Okay.
So what are these means? Why do you have different means means? Can you just clarify like to how is this used in well development means? So how do I know which one to use? Like kill -2, kill -3 means I got the example of ls and echo $? Means I do that all the time. And if I get a $? As a non-zero, I do with the exit of, I say exit 100. So that's what I do. I don't know whether that's the correct way or not. Exit some other non-zero, which indicating that it's something is a failure, and I stop the process. So, but I don't understand how this sig variable means, because all application all major the development for all the products use this, and I see all this every time. So I'm trying to understand which one to use when a process fails, like which one it will be used. Like one or two example maybe would be.
See, sig int, right? Okay, everything starts with the term called sig. Okay, sig stands for signal. So we are sending a signal called int. Int stands for interrupt. So basically, when this signal is sent, that particular process is interrupted.
Okay.
Right. Similarly, 9 stands for killing. That means forcefully it will completely kill the process, irrespective of the state.
Okay.
All right. So you were asking about what the application where you will make use of this. See, okay. I'll give you another example. Okay. So I have written a script. What the script does is, it will. Okay, say I have a database related script that I've created. It basically what it does is it will install the database. Corresponding to the database, I have created some folders where I want to store the configuration files, new config files where I want to store the logs, everything, and I have started the database service. All right. So every time what it does is, I've tested something. The next time I come and when I want to test a new scenario, what I want to do is I simply want to rerun this script and make sure that again the setup comes up freshly. You're getting my point, right? That means all the structures should all the packages should get reinstalled. Whatever folders I've created should get recreated again.
Yeah.
So what I did is, in the same script, what I do is, apart from the setup, what I'll do is, what I'll say is, I'll simply stop the process. I'll check if there are any additional processes, corresponding processes running. If they are still running, I can simply go with the kill command. I can use the kill command in order to stop that process.
So you do kill -9 the process.
So kill -9 to forcefully kill the process.
Forcefully.
So if it is like forcefully, so if a particular process is it's like dependent on other processes. So that is the example I've given you. So when we kill a process, usually, so if it is dependent on other processes, sometimes it gets stuck. So I can give you one example called as a zombie process. Okay, so a zombie process is where the process gets killed. All right. So say there is a parent process which has created a few child processes. Okay, so whenever a process gets created, an entry will be made in the process table. All right, the corresponding entry in the memory, there will be an entry made in the process table. So when this particular process gets killed, so what happens is this information must be passed to the parent process, so that the parent process will check the exit code of the child process, and then it will take the next step, and it will remove the entry from the process table. So sometimes there is a communication between the parent and child process. All right. So in those scenarios, what we can do is we can forcefully send a kill -9 so that it will be routed to the parent process and ensure that the child process is completely killed and removed from the process table.
Okay.
So
processes should be killed before the parent to make sure the process is.
So it's like when there are interrelated processes, sometimes the process hangs or it doesn't get killed using kill. So specifically in those scenarios, if kill doesn't work, then we go for kill -9.
Okay. Got it.
Okay. All right. And yeah, there are some other commands. The another one is vmstat, which is the virtual memory statistics. All right. So you'll get this metrics using the memory metrics, swap metrics using the free command also. But here the advantage is you can say, what I can do is I can set up a delay here. Okay. So if you observe my screen, right, what I did is I've set up a delay of 5 seconds. That means I want this command to continuously exit and generate the metrics every 5 seconds. All right. So that means you can make use of this in automating and in generating the complete statistics over a period of time. You got it, right? You can correlate it to a scenario. You can generate the virtual memory logs in a particular location. You run the script, you keep generating these metrics, and then you can run some additional utilities in order to generate the average memory statistics over a period of time, like a day or a week, like that. So this is something which you can modify, and so this is the interval, how we set up the interval, and we have some other options here. The other arguments that you can check with vmstat. Yeah, that's mostly we go with vmstat -a that displays, as mentioned here, active and inactive memory. So what we'll do is we'll try running some database software all right, and then perform some try to dump some content or perform some read operations automatically, so that the memory gets loaded, and then keep running this VM stat in the background, and then we can generate some metrics in order to see how memory consumption is happening. So that is the that is how we can replicate kind of a real life scenario where some application runs as the memory usage keeps getting increased. Similarly, we have another command called iostat. Alright, so this iostat, it talks about the reads and writes that are happening in your system. So these are the device files and the corresponding read and write operations. So even iostat can be automated. We can keep it in a script and we can keep continuously generating. So mostly it would be pretty much helpful when you try benchmarking some of the features or database features where you want to check the kind of read or write operations that are happening. You can calculate the average metrics out of these values for a period of time. I mean, since my system is idle, you can mostly see zeros here. Yeah, I'll finish the slides, and if you remember in the second module, I had to quickly finish explaining the same HTTP Apache server configuration. So I will explain you. I have already installed HTTP and I have configured in the sense I've created a location for ks.cfg. So I'll show you that so that we can cover both the aspects, and in the next class I'll show you how to perform the installation by taking the ks.cfg from the HTTP service. Okay, so I'll show you that. Let me finish these slides and then I'll go to the HTTP configuration. So yeah, some of the comments that I have missed are, so for the top, as you can see, the total, it gives you the total list of all the users and the corresponding process IDs. So you can go with even -u command in order to list the user specific processes. Okay, and similarly you can set up a delay time for top as well. I'll quickly check for the commands that I have missed. Yes. See, we can just wanted to mention this particular command. So if you address, so ps-eaf prints a set of list default variables and the values would get printed. So if you want, we can either go with -e and o option. As you can see here, we can mention the specific variables or the values that we want, and we can filter it like that using -evo. So I mean, this is just one of the important arguments. I'm mentioning it here. Yeah, PS3 is just to, if you remember the file system structure that I mentioned in the beginning class, like inverted tree structure. If you want to see that inverted tree structure, you can use the PS3 command, starting from the parent process, how all the child processes are distributed or how they are generated. So it just gives, the command gives the entire tree structure for you. So we have seen kill. Yeah, the next is the nice command. Okay, so when we run a top command, actually all the processes that are running in the system will have a default priority assigned to them. All right, so this is all about, I mean, there are two important commands with respect to that would help us in changing the priority of the processes. Say you want to suddenly start a run process, that means the CPU, we are trying to get the CPU time according to the priority. Okay, So what you want to do is you want to run a process and you want that, rather than waiting in the queue, you want that to get executed quickly. So what you can do is rather than priority it later, you can change the priority of the process in the beginning itself before starting the process itself, and you can trigger the process automatically. It will be given higher priority. Okay, so that is one way of doing it. So we see the command is a nice command. So if you want to see the priority of the processes, so here in the top command there is something called PR. Okay, so that stands for the priority of the process. Or if so, the previous top command that I mentioned, wherein we use ps space -eo, all right, followed by we can give pcpu and pri, right, cmd, and then I'll keep it simple, PID, PRI. Okay, so this is the list. See, so this is the command that is getting executed, and this is the process ID, and this is the priority that has been set. Okay, so there is a range of these priority values from negative to positive. So usually negative is the higher priority and positive is the lowest priority. So this is how we can use of this ps space -eo argument. So we can just list out the arguments that we want, process ID, or you can even print the CPU, you can even print memory, and then you can sort it. All right. There is a command called, I'm just trying to explain the usage, how this command is beneficial. I mean, rather than using EAF, we can list all these three, right? And then I can say sort. Okay, so this would get sorted. We can do normal sort. We can sort on a specific column from this list. Say we have printed CPU, okay, and then we have printed memory, or we have printed the priorities. We can sort that particular column, and then we can what you can do is say pipe head -10. All right, so for that particular parameter, say CPU, you will get the top 10 CPU consumers, or the top 10 memory usage, processes that are consuming memory, highest memory consuming processes, highest CPU consuming processes. Like that, we can filter and get that list as well. We can keep that handy. Those commands for getting the top consuming processes. All right. So here, I was talking about the priority. So this is how we can check the priority of the processes. And so the command, in order to change the priority, or if you want to initiate a process with with a higher priority, you can do that in the beginning itself. So there are two commands. One is nice, another one is re-nice. So if you want to start a process with a highest or lowest priority, you can start it like this using the nice command. Or you have there is some process which you have already started and it is running slowly. What you can do is you can modify the priority of that particular process. So it's like, say suddenly you want to run a process, there are other processes which are not of priority. You can bring them back in the queue. You can change their status to, you can prioritize them. You can change the status to of less priority, and you can, whatever process that you want to quickly start executing, you can set it up with the nice. Okay, so nice is for starting a process. If you want to change the priority before initiation itself, so at the time of initiation you set the priority and start the process. If there is a process which is already running in the system, if you want to change the priority, then the command is pretty simple. So this is the priority which I want to set, and this is for the process ID. So there are two ways. You can set it at a user ID level, or you can also set it at the user level. That means for this particular user, all the processes that are running with this particular username, you can change the priority for all such processes. All right, so that's pretty much about all the commands that we have seen in this module. So what I'll do now is I'll show you regarding the setup of ks.cfg as a part of the HTTP service. Alright, so say simply HTTP or Apache server or service. Okay, so what we are trying to do is we are trying to it's like host a site wherein we will keep our ks.cfg file. Alright, so whoever hits that HTTP link, they'll be able to access the ks.cfg. Similarly, the same link will be passing it as a parameter to our kickstart setup. Okay, so how do we set it up? So ks.cfg is something which we can get it from our system itself. If we want, we can make changes to it. So with respect to HTTP, I'm just telling you the steps. Yum install httpd. Httpd is the daemon. So when you use yum, it will pull that package from the repository and it will try to install it. So for httpd, the important configuration file is /etd. Under etd you have httpd and conf. There is another directory. Under the conf you have http.conf. Okay, so here since this package is already installed, ideally when you use yum install, it will pull the package and it will ask you for a confirmation. Once you install it, the configuration file would get generated, and initially the service won't be running. We need to make the changes in the configuration file and then start the service. Alright, so see, it says this is already installed. Okay, so we install the service and then we open the corresponding configuration file. etc httpd conf. Okay, this is the only file where we will be making the changes with respect to the service. Okay, now here, now let me tell you the changes that I have made. I've simply added the URL which is my host name here. I've set my host name to www.nsk.com. Alright, so by default HTTP service it runs on port number 8080. Okay, I will, so after this configuration I'll show you how to list and check all the ports that are currently open and which are in listening mode. Alright, so here, so server admin, so this is the root user. Okay, so we define some basic parameters like the host name and then my server name. Either we can give the IP address or we can give the server name as whatever you have set for your host, or you can give localhost. Alright, and then we have something called document root here. So by default, when you install a HTTP service and you start the service, alright, so you start the service and you try to access your IP address. Okay, I have it here. Let me show that to you in the Firefox. So what happens is, whatever I have defined here, host name at this particular port, this particular service is running on this host on this particular port, right? So in the URL what we give is either the host name or the domain name followed by :80, then it will start the service. Okay, so when it starts the service, so this is the folder. Document root is the folder which contains the default files where www.html. So usually when you install the service, there /html folder will contain your index file. It's like welcome to HTTP service, something like that. Okay, see that. Okay, so even this structure will be created by the HTTP service itself. Alright, so that is your index.html. Okay, so what we can do is let me finish this configuration. Okay, so the list of parameters that we define here are, the first thing is the host name, and we'll be running it on the default port. We are taking a very basic configuration of Apache server, and then we define the host admin as the root at the domain, whatever we have mentioned. Okay, other than that, so there is something called index file which is there, that is already there in your system the moment you run the service. Okay, so before with these changes that I've mentioned before, we can start the service, and what we can do is we can simply hit the URL that I've mentioned. Okay, so here you can see there is something called sample page. So it's the same. There is no HTML, nothing. It's just a text which gets generated. Okay, so in this you can even place HTML files and all. Okay, so by default this is the default configuration that is available. Now what I'm trying to do is I have defined another folder here. Okay, so let me show you that. Okay, so under var ww I've created a folder called ks. Alright, and this is the alias name. Alright, and what I did is I've kept the ks.cfg inside this particular folder, and there are some permissions involved. So what we are doing is it follows an order here. Okay, so order is first allow and then deny. Okay, so this is the order in which it has to follow. There is no entry for deny. We are simply saying allow from all, so anyone can access this particular page. Okay, so here if you see here, I'm just hitting this particular hostname colon 80 port. Okay, and it is displaying me okay. So here what happens is, for this structure var ww error, okay, there is an alias name created. So if there is an error file, automatically followed by the website address, you will get to see the error files somewhere in this location if they are generated. Alright, similarly there is an alias name created, so whatever comes here, ww var ww html, inside that we have index.html, so that index.html gets printed directly here itself. Okay, so similarly the structure I have created is ls var ww ks. So for this I have created an alias name called ks, so the URL will be followed by that. So if you remember, right, so what we did is, regarding permissions, we have granted allow from all, that means grant everyone, so anyone can access this. The same concept. Alright, so in this in the place of configuration file, if I copy and keep all the RPMs here, okay, and then what I can do is I can simply point my yum repos.conf, that location. In that configuration I can simply point this particular folder. Automatically yum will, so why, as a part of creating a local repository, that's what we have seen. So they have created a HTTP service, very basic configuration, create a particular folder, create an alias name, give access as per your requirement. So only those people will be able to access. Once you hit this folder, you will have all the list of files here. Okay, so for case.cfg, what we will do is we will give this path. Alright, we'll say that the configuration file is present in this path and this service is available over the network and everyone has access. So we'll simply give this. Automatically the kickstart file must be taken from this particular location. Okay, so I'll just show you that configuration once again. So vi okay, so this is what I did. So there is already, you will have the existing alias name configurations. So if you see here, there is a folder called icons over there. So here, even for that folder, allow from all. Similarly, you create a folder for your configuration for ks.cfg, and you can mention who are allowed and who are not allowed. And all right. Okay, so once this is done, so once we have configured this, so we have installed using yum, and then we have made changes to the configuration file. We have created the corresponding folder over there, and there is a concept of permissions. So what we have to do is we need to give permissions to the directory that we have created. Okay. For example, if I go there, where ww, okay. See, if you see here, right, this is the folder that I have created. Say I have created another folder. Okay, so here we need to make sure that this folder has all these permissions. Okay, we'll go through the permission part. So basically, other than the owner, okay, this is the group and others. So they need to have proper permissions in order to access this folder. Otherwise, we'll get the error if we try to access the contents of this particular folder. Alright, so what we do is I have created this. I have given proper permissions not only to this file but also to the content which is there inside case. So tomorrow I might keep some more content, so I need to make sure that all the files inside case have proper permissions. Usually yeah, we'll see that in the permission part, what permissions must be given, and how we can block the users with respect to permissions and all. So we need to ensure that the file has proper permissions. Once that is done, we simply has to etc init.d httpd. So check the status. So by default it will be stopped more after installation. So we simply have to start the service. Alright, since it is already started, I am just showing you. I will restart the service. So the moment I start the service, the URL will be up and running. Okay, and also what I do is I use chkconfig, and it's okay. So you should also make sure that in the current level that particular service is up and running. So currently I'm in run level 5, it is on. So you should also permanently update that change using chkconfig, so that next time you restart your system, the service will be up and running. So this is how we configure a basic HTTP service. Alright, So in the next session, I'll fix my VM issue, and then we'll pass this particular URL as a argument to the kickstart file and see how it's gonna start. And also similarly, there is another service. So there are different ways of doing network installation. One is using HTTP. So there is something called NFS where we create shared folders over the network. So we can create a shared folder and we can keep our case kickstart file in that, and we can give the path of that just like that, just like HTTPS. So the representation varies. All right. So if it is you might have heard about FTP services. So accessing the FTP site is different. So like that, we'll see other ways as well. All right. So that's pretty much for today. See you in the next class tomorrow.